Okay, so this morning we're learning to find the 6 trig ratios of an angle in standard position. So a lot of new stuff. I don't think it's really hard stuff, it's just a lot of new stuff all at once. So we'll go slowly through it and hopefully everyone will feel good about it. And then this afternoon just build off that. Okay, so it's actually not bad. Friday. Then when we come back, we start something kind of separate. There's a lot of separate little parts to break down. All right, so we're learning to find the 6 trig ratios of an angle in standard position. So for a right triangle, there are 3 what we call primary trig ratios, and those are the ones SOHCAHTOA. Okay, so SOHCAHTOA are considered the primary trig ratios, sine, cosine, and tangent. And then there's also 3 reciprocal trig ratios. And they're called, they have weird names, cosecant, secant, and cotangent. Okay? And I've listed them for you, so you should already know the primary ones. Okay? Now, the secondary ones are called the reciprocal trig functions, and that's because they're the reciprocals of the primary. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, just flipped. Okay? If cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And if tan is opposite over adjacent, cotangent is adjacent over opposite. Okay? They're not on your calculator, as you'll notice. Okay? They originally were found or used because if you had a sign that was like 0.05, it was nicer to have a bigger number. So 1 over 0.05 is a bigger number to use. So back before calculators and everything, if your sign was a hard number to work with, you would take the reciprocal of it and make it an easier number to work with. Now we have a calculator. So the calculator does all that for us. You don't need them as much anymore, but they're important. They have graphs that are associated with them that you'll learn in advanced functions next year. Okay, this year we're going to learn the sine and cosine graph next Thursday that I have you. Okay. All right, so here we start off with an easy question then. State the 6 trig ratios of angle theta. So according to angle theta, I think you guys hopefully will all agree with me that this would be considered the opposite side. This would be considered the hypotenuse. And this would be considered the adjacent. And when I'm listing them off, I always do them in pairs because I know they're reciprocals of each other. So if I do sine first, I'm going to write the sine of angle theta is 5, the opposite, over 13, the hypotenuse. And that's all that's doing is stating the sine ratio. Okay? And then right after I do the sine, I would do the cosecant because I know that all I have to do is take the sine ratio and flip it upside down. Because that's going to represent hypotenuse over opposite. And then I would do cosine. Cosine of angle theta is adjacent, which is 12 in this picture, over hypotenuse. And then immediately after I do cosine, I'm going to do secant. And that's the reciprocal, so hypotenuse 13 over adjacent, which is 12. And then the third ones I'm going to do are tan and cotangent. So the tangent of theta, opposite over adjacent, 5 over 12. Cotangent of theta, flipped upside down, so adjacent over opposite, 12 over 5. So those are the 6 trigonometric ratios of angle theta. Okay? Any questions? Anything formula? Okay. This year, we will look at trigonometry from a different perspective. We'll define angle theta in standard position to be the angle between the positive x-axis. So now we're putting it on an xy axis. So angle theta is always going to be the angle between the positive x-axis and what we call the terminal arm of the angle. So x-axis, the positive x-axis is considered to be the initial arm of the angle, and the terminal arm is where the angle stops. So you can see that if the angle is in the first quadrant, so this is quadrant 1, it's going to be an angle between 0 and 90. But if, say, your terminal arm were over here in the second quadrant, your angle would be going all the way from here over to here. So it would be an angle that's between 90 and 180 degrees, or an obtuse angle. Okay? If your terminal arm ended up being in the third quadrant, the angle would be between 180 and 270, a reflex angle. Okay? And you could even have your terminal arm being in the fourth quadrant, which then gives you an angle between 270 and 360. Okay? So instead of just having angles between 0 and 180 with triangles, we can have angles all the way between 0 and 360.
I'm sorry, Miss Martha. Hi. Is this Angela, please?
Yes.
Thank you. Welcome.
All right, so just to break stuff. Yeah, but that's what's coming. Okay, so let's work with this diagram. So what we normally do then is we take our ruler and draw a triangle. So draw a straight line down to the x-axis to form a right triangle. Now this point here says that it has coordinates x, y. Okay? Which would mean that this length from 0 to here would be x. Everyone agree that if this is the point x, y, you'd go over x and up y? So this length here is x. And then this length here, you would go up y, is y. And so now we know the lengths of two of the sides of our right angle triangle, x and y. Okay? Depending on what the coordinates of that point are. Okay? But I want to know what this third side is. Because it's a right angle triangle, it follows the Pythagorean theorem. Okay? We call this side r. R stands for radius. Okay? Because you can think of this as this terminal arm as being able to move in a circular way around this axis. So we call it r for radius. And r is they're related. Rx and y are related by the Pythagorean theorem for right angle triangles. So if you remember the Pythagorean theorem, it was c squared equals a squared plus b squared. But what had to be special about c?
Had to be squared? Or
Which side did it have to be? The hypotenuse? Everyone agree? So in our case, c is going to be r, and instead of a and b, we're going to use x and y. So, sorry, not x and b, x and y. So this equation here is the relationship between rx and y. Okay. So there's a Pythagorean relationship between x, y, and r. So if you know two of them, you can always find the third one using r squared equals x squared plus y squared. Okay? So, if we look at angle theta here and we want the 6 trig ratios, the sine of angle theta, so if we look over here, the opposite side is always the y value, okay? So the opposite side is the y value, and the hypotenuse is always the r value. So in grade 11 trig, we think of sine of the angle as being the y value over the r value, which means the cosecant is going to be this flipped upside down, the r value over the y value. And the cosine of angle theta is going to be the adjacent, which is always going to end up being the x value in this case, over the r value, which means secant of theta will always be the r value over the x value. And the tangent of angle theta is opposite over adjacent, but in grade 11 we're going to think of it as the y value divided by the x value, which means the cotangent will always be the x value divided by the y value. So you can think of, it doesn't matter where this terminal arm lies. According to the angle theta, my opposite's always going to be my y value, okay? Hypotenuse is always going to be the r value, and adjacent is always going to be the x value, okay? So this correspondence will always work. X will always be adjacent, y will always be opposite, and r will always be hypotenuse, okay? Great. So here's our first example. The point 34 is on the terminal arm of angle theta. Sketch angle theta in standard position and determine the 6 trig ratios. Determine angle theta to the nearest degree. So you're going to start off with your ruler, and you're going to draw an XY axis and label it. So the diagrams are always out of 3-ish marks, okay? So they're an important part of this grade 11 trig, is drawing the diagrams. If you have to draw 2 of them, they're at 6 marks, lots of marks for diagrams. So make sure that you always get all the diagrams correct, okay? So the first thing we're going to look at for this question is the point 34. Now we're not going to use grid paper, but we want to know which quadrant this is going to be in, okay? How do I know whether it's going to, the terminal arm is going to be in this quadrant, this quadrant, this quadrant, or this quadrant? So?
Well, the x and y are positive, so it must be one of the.
X and y are positive. So if you were thinking about plotting the point 34, you'd go over 3 and up 4, you'd be in this quadrant. Does everyone see that? Okay, so we're just going to take your ruler and draw a terminal arm somewhere in this quadrant. And the terminal arm is just like a ray. It starts at the origin and has an arrow on the end of it. And then you're going to pick a representative point along your terminal arm somewhere. And that point in our case is the point 34. Okay? And then you're going to take your ruler and draw down so that you've made a right angle triangle with the x-axis. Always with the x-axis, never with the y. And that keeps your x, y, and r always consistent with your means. So there, and show your right angle. Okay, Now, one mark under your 3 is always showing angle theta. So it says sketch angle theta, so obviously angle theta has to be shown. What is actually angle theta? So it's always the angle from the x-axis to the terminal arm, and it's directed, so it needs a little arrow. So from the x-axis to the terminal arm in a counterclockwise direction, and then we label it theta, so you can either on this side or this side, it doesn't matter to me. I'm going to put it here, theta. So it's a circle with a line through it. There's theta. And then you have to label the 3 sides of the right triangle. And then you've drawn a labeled diagram of angle theta. Okay? So you need the 3 sides of this triangle. Now 2 of them, because we know the point, are kind of given to us. This is x, so this is 3, this side of the triangle. This is y, so this is 4. And we know that r squared equals x squared plus y squared. So we can figure r out using the Pythagorean theorem. So we get r is, in this case, we get exactly 5. If you get like the root of 26, something that's not nice, just leave it as the root of 26. Don't do decimals. Okay, we want everything to be exact. In this case, it works out exactly, so we can label the 3rd side. So now this would be 3 out of 3. You labeled the x and y axis, drawn on the terminal arm, made your right triangle, drawn an angle theta, and labeled all 3 sides of your angle. Okay, so that's what a labeled diagram of an angle looks like. Okay, gotta have all that stuff on it to get perfect on the diagram. Okay, determine the 6 trig ratios. So now we just have to know them. So the first one is sine theta is y over r. So if we're looking at our picture here, you might want to do this for help for now. This is the y value, this is the r value, this is the x value. Sine is always going to be the y value over the r value, so 4 over 5. And it's paired with cosecant, CSC, cosecant of theta is r over y, or whatever sign is flipped upside down, sorry. 5 over 4. And then cosine theta is always x over r, so for us that's 3 over 5. And secant theta is the one it's paired with, flipped upside down, so 5 over 3. And then tan and cosine. So tan theta is the y value divided by the x value, so 4 over 3. And then the cotangent of angle theta is going to be 3 over 12. Everybody good for that? So this would probably be 3 marks, this would be 6 marks, okay? And then now we have to find angle theta. Okay? So to find angle theta, I like to take it off this and just draw the right triangle. And you'll see why when negatives are involved, I really like doing this. Okay, so I just want to draw a plain old right triangle where I know the 3 sides. I call it a grade 10 triangle. So the triangles we just did. This, in this case, this is theta. So if I were to say, find this angle, you would choose 2 of the sides. And I like tan, so I usually always use tan for this. So I always find my opposite and my adjacent. And I have my hypotenuse, but I always use tan. So the tan of angle theta is the opposite over the adjacent. So the tan of angle theta is 4/3. So theta is the tan inverse of 4/3. Which means angle theta is actually 53 degrees approximately, and round to the nearest degree is fine. Okay, so we've done everything the question asked for. Sketch angle theta in standard position, determine the 6 trig ratios, determine angle theta to the nearest degree. Okay? So the Cartesian plane is divided into 4 quadrants. The terminal arm of an angle can lie in any of them. So there's their names, usually used Roman numerals, but I don't care, you can just use regular ones, but just so when you're looking at a textbook, you know, they normally use Roman numerals. So if your terminal arm's in angle 1, as we talked about, your angle is going to be between 0 and 90, because 90 degrees makes a quadrant. If it's in the second quadrant, your angle will be between 90 and 180. Your terminal arm's in the third quadrant, and it'll be somewhere between 180 and 270. And if it's in the fourth quadrant, it'll be between 270 and 360. Okay? Okay, so here's our next question. The point P negative 815 is on the terminal arm of angle theta. Sketch angle theta and state its 6 trig ratios. Determine angle theta to the nearest degree. So same question, except for probably different quadrant, right? So you start off with your x and y axis. Label. And then you look at the point and you figure out which quadrant that point would be in. 2, because it's a negative 8. I was plotting negative 8, positive 15. It would be in the second quadrant. So I draw a terminal arm in the second quadrant. Arrow on the end. Pick a representative point along it, and then draw a vertical line to the x-axis to make a right angle triangle. Hi, so I'm good for today.
You're good?
Yeah.
Yeah.
Happy Friday. No, I don't have any photocopying.
Okay.
Thanks. Yeah, you too. Okay, so the point negative 815 is on the terminal arm of angle theta, so we should be able to put on 2 sides of our triangle. If this point is negative 8 and 15, that means that this side here is negative 8. Is everybody good with that? And this side here is 15. And then I can figure out the other one using Pythagorean theorem. So r squared equals x squared plus y squared. So negative 8 squared plus 15 squared. We get 17. And then we forgot to label the most important thing, or we didn't forget, but we left till the end, is that's actually angle theta. So angle theta, remember we said if we're in the second quadrant, it's going to be an angle between 90 and 180. So the angle starts here and it goes counterclockwise until it hits the terminal arm. So this angle here is angle theta. Notice how it's not in this right triangle we drew? It's not in the triangle we drew. that's related to the triangle we drew, and I'll show you how to get angle theta when we get there. Okay, so this is fully labeled. This is a perfect diagram, okay? Now we go on to stating the 6 trig ratios. Okay, so we're going to start off with sine and cosecant. So the sine of angle theta is the y value, which is 15, over the r value, which is 17. The cosecant is upside down of sine, or r over y. Cosine is the x value, so negative 8 over the r value, 17. And secant, so a lot of people write 17 over negative 8, but if you looked up your answer in the textbook, the negative's always up with the top number. Is everyone good with that? Okay, so it will get bumped up, so you might as well bump it up so that you can do it all in one step. And then the tangent of angle theta is the y value over the x value. So 15 over negative 8, so we bump up that negative again. And the cotangent is the x value over the y value. So there's our 6 trig ratios. So now we actually have to find angle theta. So this is where we draw our grade 10 triangle, I call it. And we ignore all negative signs, because in grade 10, no sides were negative. It's hard to think of a side length being negative, so we're going back to we call this a grade 10 triangle. So all my sides are positive. And we want to find this angle, and this angle here is not theta. So we actually call it, has a name in grade 11. It's called alpha, which looks like a little fish. Like that's alpha. Okay, so the Greek letter alpha looks like a fish. Okay. Why would it be helpful if we want to know theta to find out this angle here, alpha? Why would that be helpful? Son? Theta and alpha add up to 180. So theta is going to be 180 take away alpha. That's why. Okay? So if we know alpha, we know it fits in there, we can find theta. So that's why we're using our grade 10 triangle. I always use tan, so tan is opposite over adjacent. So I'm going to do tan of alpha equals 15 over 8. Alpha is going to be the tan inverse of 15 over 8. Or approximately tan 15 over 8. Oops. 62 degrees. But we want theta. So I always like to write out this statement showing that theta is exactly 180 take away alpha. So no dot with my equal sign because that statement is 100% true. But because alpha is rounded, theta is going to be approximately, and then I just do 180 minus 62, 118 degrees. Is that good? I just want to go back to this diagram now that we've done one of these. So if your angle's if theta's in quadrant 2, theta is always going to be 180 minus alpha. Okay? if your terminal arm's in quadrant 3, theta is going to be 180 plus alpha. And if your angle's in quadrant 4, think about where alpha would be. Alpha would be here. So theta would be 360 all the way around, take away alpha. Okay? So if you're in quadrant 2, theta is 180 minus alpha. If you're in quadrant 3, theta is going to be 180 plus alpha. And if you're in quadrant 4, theta is going to be 360 minus alpha. And what if you're in quadrant 1? Theta is alpha. Or sorry, theta is alpha, but I wrote it backwards. Theta and alpha are the same. You don't have to find alpha, it's theta. Okay? So that's a good guide if you forget. All right, the point Q, -24, -7 is on the terminal arm of angle theta. Sketch angle theta in standard position and state each of the following. So we're going to draw our diagram first. So what quadrant is angle theta going to be in? Quadrant 3. Okay, so a negative x and a negative y. So -24, -7. Again, it doesn't matter to me whether it looks realistic or not. It's just representative. So don't worry if you think your slope's not right, that's not important. Remember always to make your right triangle with the x-axis. That's where you can go the most wrong if you make it with your y-axis. Definitely. So this point here has an x value of -24, which means x is -24, and a y value of -7, which means the y is -7. And then we have to calculate r using the Pythagorean relationship. Remember, when you square a negative number, you always get a positive number. You keep getting perfect squares, but remember, if you don't get a perfect square, just leave it as a square root. So now you have 3 sides labeled, but the most important thing you put on your diagram is angle theta. So it starts at the positive x-axis and goes counterclockwise until it hits the terminal arm, and it's got an arrow on it, it's directed, and then you can label it theta. So that's angle theta. So it's going to be between 180 and 270 somewhere. Okay? So that is sketch angle theta in standard position. So state each of the following. Sine theta. So it's always going to be the y value over the r value. So for us, that's going to be -7 over 25. If it helps you to put x, y, and r on your diagram, then do that. cotangent of theta is the y value over the x value, sorry, the x value over the y value. So it's going to be negative 24 over negative 7, but that wouldn't be the answer on the back because the negatives cancel each other out. So you want it reduced, at least if there's two negatives, you want to write it as a positive. Good. So that would be the cotan. And then sine squared theta plus cos squared theta. So this is probably terminology that very few of you have seen before. Okay, sine squared. That's just like a short form of writing the sine of theta squared. So rather than having to put brackets and squared, they came up with, if I want to square a sine, I'm just going to put the squared in there. Okay, so they mean the same thing. Plus cos theta squared. So now that we know that, we can look on our diagram to figure out what is the sine of theta, or actually we actually wrote it down up here. It's negative 7 over 25 squared. And from our diagram, what would be the cosine of theta? That was what the sine was. Oh no, it wasn't the sine. It's cos x over r, so it would be negative 24 over 25. Does that make sense? The cos of theta would be x over r, so negative 24 over 25. How do you square a fraction? Oh. Square both the top and bottom. So negative 7 squared is positive 49. 25 squared is 625. Negative 24 squared is 576. 25 squared is 625. And you're lucky it's already got a common denominator. Both have 625 as the denominator, so you can add the numerators. And they add up to 625 as well. And 625 divided by itself is 1. And then they want angle theta. So look at this triangle here. So I'm going to draw it down here. See how far up I can go. So I want to draw this triangle. Now alpha fits right in here. So this is alpha. It's always between the x-axis and the terminal arm, if it's in a different quadrant other than the first, right? This is my right angle. Forget all the negatives, so we're thinking of this as 24, 7, and 25. And to find alpha, I want to use tan. So the tangent of alpha is the opposite, which is 7, over the adjacent, which is 24. So alpha is going to be the tan inverse of 7 over 24. Which is 16 degrees, approximately. Okay, so how does that help us find theta again? So when we're in the third quadrant, theta is 180 plus whatever alpha turns out to be. And in our case, that's going to be approximately 196 degrees. which is between 180 and 270, which is a good check to make sure it makes sense. Okay. All right, so here's a different way of giving you information. Angle theta is in the fourth quadrant, and the secant of theta is 13/5. Sketch angle theta in standard position. Determine sine theta and cosine theta. Determine the angle to the nearest degree. All right, so it says it's in the fourth quadrant. So we're going to draw, start off with our diagram, drawing a terminal arm somewhere in the fourth quadrant. So we know from our definitions of our ratios that the secant of an angle is the R value divided by the X value. Okay? So when they give us 13/5 like this, that means it's the R value over the X value. Okay? So that means on our diagram, R is 13, and X is 5. So this time, it's the Y value that's missing. Does everyone see that? But they're still related by the Pythagorean theorem. So that Pythagorean relationship still holds true. It's just that we have R this time and X, but it's Y that we don't have. So I can replace R with 13 squared. X is 5 squared. And then I'll just leave Y because that's what we want to solve for. So 13 squared is 169. 5 squared is 25. And then to get Y by itself, we would subtract 25 on both sides first, which is going to give us 144 equals Y squared. And then we'll get that Y is either positive or negative 12. And it depends on the quadrant. So in quadrant 4, Y would be positive or negative. Which one makes sense? Negative because you go 5/5 down 12 to get to that point. So in quadrant 4, Y is negative 12. So one thing that's really important to know is R is always positive. Okay, so R, the radius is always positive. But X and Y can be positive or negative depending on what quadrant you're in, right? So if you're in the first quadrant, X and Y are both positive. If you're in the second quadrant, X is negative and Y is positive. If you're in the third quadrant, X and Y are both negative. And if you're in the fourth quadrant, X is positive, but Y is negative. So always make sure your diagram makes sense from that standpoint, okay, of how you would plot points, basically. So now we have the three sides labeled, but we're missing the angle again, which is the most important thing. So remember, it starts at the positive x-axis, goes around counterclockwise until it hits the terminal arm, and then that's angle theta. So it's going to be between 270, which would be down here, and 360, which is back around to the start. So we start at 0, 90, 180, 270, 360. So those are like your guideposts there, so you can make sure your rows make sense. All right, so check. Sketch angle theta and standard position. B, determine sine theta and cotan theta. So you just have to know what their formulas are. Sine theta is the y value over the r value, so it would be negative 12 over 13. Cotan theta is the x value over the y value. So it would be 5 over negative 12, but then I would bump that negative up. X over y. So done. And C is to determine angle theta, which means we have to find alpha first. Okay? So we want to draw this triangle out. It's a right angle triangle. This is alpha. 5, all positive sides when we're finding alpha. So alpha, according to alpha, this is the opposite. Hypotenuse, adjacent. I'm going to choose to use tan. So the tan of alpha is 12 over 5. It's opposite over adjacent. Alpha is the tan inverse of 12 over 5, which is approximately 67 degrees. And then we know that in quadrant 4, theta is 360, so all the way around minus alpha, which will turn out to be approximately 293 degrees, which makes sense between 270 and 360. Okay. Angle theta is in the third quadrant, and cosecant theta is negative root 65 over 4. Sketch and label angle theta, determine the other 5 trig ratios, and determine 2 times sine theta times cos theta. Start off with a diagram. Third quadrant is this quadrant. All right, so you need to know that cosecant theta is r over y. Okay, so that's defined, that's the definition of cosecant, the r value over the y value. So knowing that r is always positive helps us a lot. Because now we know the negative sign has to go with the 4. So r over y. So that means that r is positive root 65. And y is negative 4, which makes sense with the diagram that y would be negative. Okay, r is always positive. So now it's x that we're missing, so we can still use the Pythagorean theorem. So this time we know r is root 65, so square root of 65 squared equals x squared plus brackets negative 4 squared. Square undoes square root. So all you're left with is 65 when you square the square root of 65. Okay? And when you square a negative number, you get a positive. You're trying to get x by itself, so you would subtract 16 on both sides. So that gives you 49. Square root, and you get plus or minus 7. And then you have to go with the quadrant. So for quadrant 3, it makes sense that x would be positive 7 or negative 7. Negative 7, good. And then we put theta on. So starting at the positive x-axis, around to the terminal arm, that's our angle that we're talking about. So between 180 and 270. Okay, so that is sketch and label angle theta. B is to write out the other 5. So we already know cosecant, but write out the other 5 ratios. So the sine of angle theta is the y value over the r value. So for us, that's negative 4 over root 65. We already know cosecant. Cos of angle theta is x over r. So that's negative 7 over root 65. And secant of angle theta is r over x, so negative root 65 over 7. I'll just bump the negative up. And then the tangent of angle theta is the y value over the x value, so that's negative 4 over negative 7. But if they're both negative, what do I do?
Get rid of the negative.
Yeah, get rid of the negatives. I'm just going to erase them if they're never there. And then cotan theta would be 7 over 4. Upside down. All right, so there's the other 5. So that's B done. C says determine 2 times sine theta times cos theta. So 2 sine theta cos theta is just going to be a number. It'd be a weird looking one. This means we take 2 and then sine theta was negative 4 over root 65. And cos theta was negative 7 over square root of 65. And then if you want, you can pretend the denominator of 2 is 1. When you multiply fractions, that's the easy one. You multiply all the tops together. and all the bottoms together. So you'll get 56 over 65. Because root 65 times root 65 is 65. So another way of thinking about root 65 times root 65 is that it's root 65 to the power of 2, and we know that squared ends as square root. Okay, or you can get the root of whatever 65 times 65 is, square root it, and you'll get 65. Okay? Figure out that number for you. In case that's the way you want to do it. Any questions? Ready to try some practice? Okay, good. First day of grade 11 trig.